All right, onward and upward. Looks like we get to move away from the gateway here and talk about the, looks like RADOS quality service, QoS.
So the idea about quality of service here is in general to do quality of service in a way that's scalable for a distributed system, and starting out with just quality of service for I/O. Syed Villa has been looking at this. I think Syed is online as well. Syed, do you want to give a little bit of background about what types of quality of service there are, and which approaches exist?
So currently we are offering three options to the client. One is the minimum IOPS that a client wants, and also the maximum IOPS that if his request exceeds that maximum limit, the OSD side will clamp at that point. And when the minimum IOPS is reserved and maximum is not reached or met, then what would be his usual share? In general, the Linux I/O or disk I/O scheduler is a fair share scheduler. So if I have 10 clients and they are requesting, the I/O scheduler simply follow a round robin fashion. So that's the basic thing, but we try to alter that a little bit by using those share, reservation, and the upper limit. So currently we are working on an algorithm which is called DM clock algorithm. It's a research paper, and so this is how we try to implement or improve the I/O scheduler on the OSD side for the Ceph.
Yeah, so that's a good general overview of the DM clock. So, like I was saying, basically a client like an RBD or RTW or some other user of Ceph would have some kind of high-level policy defining what minimum level of IOPS they would have, a maximum level of IOPS, and a proportional weight that they would be the fallback mechanism if there's extra capacity, or if the cluster is over capacity, oversubscribed, and the limits can't be met. In terms of why we were looking at the DM clock algorithm, Syed, do you want to describe some of the other things we looked at, the other algorithms?
The major issues right now, or the current focus in research domain, is the tail latency. They are more focused on the overall end-to-end latency minimization. So the DM clock is only focused on the I/O part, but there are some other part as well, like the memory bottleneck or the CPU bottleneck. So the recent approaches, they are more inclined to attack every portion of the bottleneck, like the I/O scheduler, memory scheduler, or the CPU scheduler. But that is our long-term goal. But as for now, we just focus on the I/O part. Once it is done, then probably we'll look at the other part as well to guarantee the minimum latency, the tail latency on 99% latency.
Yeah, and one thing that was interesting about those later systems that more current research is being done on is that to get those latency bounds as opposed to the pure IOPS bounds, most of them did end up having to look at other bottlenecks besides storage, like the network and the CPU, and just scheduling based on reservations there instead of just on one resource. But it also ended up having some complicated things like workload modeling and more global sharing of state about which workloads exist, and trying to schedule different workloads at different times, gain different benefits based on grouping things together in a more efficient way, which also wasn't completely obvious how to do it in a distributed system without that kind of global state, or do it in a scalable way. So the TM clock algorithm is much simpler in that sense, since it doesn't require any kind of large-scale coordination. It's simply the clients giving the OSDs information about their activity directly. So do you want to talk a little bit about the implementation for the current prototypes you're working on?
So currently I'm working on the characterized queue, which is the existing code. So I try to add some extra functionality of that code. In that code, there are a couple of functions like enqueue strict or enqueue strict front. Those functions, as I assume, are for the management messages, like that messages are not related to the IO operation. But there is one method that is regular enqueue, and which actually does the fair share of the round robin fashion. So I try to modify that function and hide GM clock algorithm under that function. The implementation phase right now, in my local machine, I'm testing with my synthetic data and hard-coded throughput, but probably next week or in the 3 or 4 days, I will able to transfer my code to the main code branch and see how it works in real life.
All right, that's good. Good plan. And let's see, talking a little bit about how this might be used, like eventually, if higher level policy could be exposed as like configuration options for RBD images that might be set on a per image basis, and perhaps configured more generically through higher level tools like Cinder and OpenStack or other like CloudStack or other management tools, provide like different classes of service to different kinds of volumes. Although it could be easily changed just based on whenever a client connects, it could have different settings. If you really wanted to change it, change the settings that often. So are there other questions about this approach in general, or?
I didn't read through the paper, so my question is: reservation, would it be the same as provisioned IOPS? So fully guaranteed IO operations?
Yeah, that's the idea. So it would be the minimum.
So how do you
guarantee.
Do you have somewhere to configure how much performance your cluster is able to deliver, or?
Yes, that's a good question.
I mean, how do you decide, even in case of, let's say, some OSDs fails and take the performance down? Is there something you say you measure before? My cluster can 100,000 IOPS, and I say you can reserve a maximum 70,000 or something like that. I mean, I guess it can't be auto-detected that easily.
In the paper, there is a concept of admission controller, and that admission controller will decide whether a new request from a client with certain reservation will be accepted or not. But right now, we do not focus on that part yet. We just try to add the functionality. If the throughput is enough to meet the client's reservation, then what will happen? We'll try to implement that part. Then probably we'll look at the admission controller as a global point of view.
Okay.
And it could be something that ends up being like done by a higher level too, like Cinder perhaps. And in a sort of like quota based on IOPS, the cluster that administrator would configure. So you could just easily multiply the reservations by the number of volumes you have and see whether you're over or under subscribed, if you have extra space. But the other piece is also that in this algorithm that it does need to have some notion of how the underlying storage can perform. We haven't really dug deeply into that yet. If the paper describes some like using a conservative bounds on that, that tends to work out right. But it's a good question about whether we can auto detect like what the performance of an OSD will be, perhaps using the existing like OSD bench code to get that parameter for the algorithm.
Okay. I guess you need at the end some way to say I know what my performance of my OSD or whatever is, and have some room for the audio replication and even the disaster recovery cases. So yeah, that you say
I think that would kind of be
of maximum or so.
Implicit. Yeah, I think that would be kind of implicit in the measurement. It would have to be. Like if we did base it on a local OSD bench, then you have to divide it by the replication factor.
Okay.
Or it could be just based on actual measurements of like sample rates.
Yeah, I guess at the end this is some administrative task, maybe. I mean, actual measurements.
Perhaps.
Also depends on how full the disk is and whatever. So also the file system below and
Yeah, it can definitely change over time. That's why it probably wouldn't make sense to make it like a static configurable in the long term. But hopefully be able to auto detect how the actual storage is performing.
So the question is where to configure it for each RVD. Would it make sense to put that, for example, in somehow an on-fly, or would it be some configuration you have to set to the RVD itself because you may want to change it later in an OpenStack environment and maybe I don't know what the workflow would be. I mean, the easiest would maybe be something as there is already some limitation stuff in libvirt and QEMU. So
so like in the OpenStack context, Cinder already has a way to like set specific policies for quality of service, and so that happens when you create a volume. So I was thinking that the way that this might be exposed at the RVD layer would be the Ceph.conf settings, and with the new RVD metadata that how I implemented the RVD specific settings can actually be set per image and stored with the image header. So they're stored in the cluster themselves with that particular image. So if you wanted to change the policy for a particular image, you can do that and have it be automatically applied whatever uses it.
Okay, sounds good.
Hi, Josh.
Hi, how am I?
Yeah, it seems I missed something. It looks like what we said is much like tomorrow topic about message. My topic about OSD message send. I guess we mainly implement this feature on OSD side, I think, because if we want to implement a scalable or distributed QoS, we need to add some like tags to messages protocol, and we need to reserve something like TCP send window, yes, something like this. Do we have any prototype about this? I'm late for this topic.
Yeah, so Syed is working on a prototype now, adding the tags to the OSD OSD app messages, and right now it's just looking at the storage I/O, and we haven't really considered the network priority settings at all at this point.
Yeah.
That's kind of an early stage in prototyping.
Yeah, maybe we can refer to a network like a switch QoS. It will implement a queuing in more detail. Maybe we can refer to network queuing, something like this. Yeah.
Yeah, I'm not sure if that would play very well with like I think some of the other papers we looked at, which looked at more than one resource, like the network and the CPU, in addition to the I/O, tended to consider all of those things together as part of one QoS algorithm instead of treating them separately, like at the switch level and also at the storage level. But looking at them in one unified system that had a view of everything. I think it's something that definitely is worth investigating. I have very good intuition for this in general, so there'll be a lot of testing and iteration as we see what works and what does not. Saya, did you see any papers that mentioned anything about this generic network QoS and its impact on the storage systems without integrating it into a larger scale algorithm?
Yeah, I haven't seen.
Yeah, I have seen a couple of algorithms that consider network, I/O, and the CPU as well. And I can give name of some of the algorithm. One is a priority master, a very recent algorithm. It says scale latency QoS for shared network storage. There's a more complicated algorithm, and they basically use different QoS mechanism at different points, and they also use a global controller that intelligently switch or tune certain parameters in certain QoS system so that the overall latency is guaranteed. For example, if the network is too congested for a certain client, or then probably they increase the I/O bandwidth of the other clients to balance the end-to-end latency. I can give the name of this paper is here. You can find it online.
The nice thing about that algorithm in particular is that it was providing stricter bounds rather than just provisioned IOPS. It was actually provisioned latency almost. So it was giving you bounds on the latency of all operations rather than just an average, which is basically what IOPS is. But there wasn't really a clear way to implement it in a large distributed system like Ceph, since it does have this global workload analysis component. It's also a lot more complex to implement, so that's another reason we didn't want to try it starting out with it, but perhaps move toward looking at other resources later. Sam, are you around? Do you have any thoughts about the like measuring the OSD performance automatically?
Can you guys hear me?
Yes.
There are simple things you can do when you're for particular known quantity sorts of operations, like an RBD class, or I mean an RBD write or read. we could measure the latency for those and get a histogram and a average latency. I think that's the best you can do. Generally, just measuring the latency for operations in the object store isn't a good idea because they're pretty heterogeneous. Recovery sends different transactions from client IO, sends different transactions from scrub, etc. So I think we'd want to do it manually up and do up, or up at the top of the client processing pipeline, rather than down an object store, is my guess.
So measuring the full path with replication included, and
no, just when Duo as the ops sends down or prepare transaction sends down a client transaction to the object store, just measure the maintain the statistics there instead of under the object store.
Oh, I see what you're saying. Yes. Yeah, that makes sense.
It's complicated a bit by sort of environmental stuff like other recovery happening or scrub happening, but you actually kind of want to capture that anyway. If you have a short enough averaging period, then you'd be able to catch transient effects like recovery when calculating the total IOP capacity. So that would be good, a feature, not a bug.
Mm-hmm. Yeah, you do want to consider your capacity lowered when you have background things going on that are taking some of it.
Although we may be able to consider those directly. Those are scheduled as part of the prioritized queue as well.
Mm-hmm.
So we might be able to factor those in if we wanted to give them a IOP reservation concept as well.
Yeah,
that might be really appropriate. Okay. Actually, not sure.
That might make a lot of sense. Either a low reservation or just a proportional weight that was as relatively low compared to clients.
Right. We'll probably have to do that anyway because they are scheduled through the same queue. So we'll have to do something to adapt the existing priorities. That could be really interesting.
So you think something that looks at the latency from the last time period window of requests would make sense?
Yeah,
time
I'm
period
trying
being
to think.
Like several minutes, or?
Well, now I'm trying to think about actually doing it at the object store level. If we gave the object store some information like, I think this is a 3 IOP or a 3 IOP transaction with n bytes of operation, we might be able to let the object store estimate its throughput that way. I think it's probably similar to the client level though, or Duo COPS. But yeah, either way, you're just going to be taking an average of IOs over the last n seconds and making decisions based on that.
Mm-hmm.
Do we want a feedback from the replicas? That's another question. Because operations when sent to the replicas need to be sent at basically don't throttle me priority, because once you've committed to performing a client operation, there is no sense in letting it throttle on the replica side. So when we schedule an op on the primary side, we're committing the replicas as well. So we may want a feedback mechanism that the replicas can notify the primary of how much work they have available. But when you're doing the scheduling in that queue, it's among 100 PGs, so potentially 200 to 300 replicas. I'm not sure there's a reasonable way to do that.
Yeah, I'm not sure there's a reasonable way
Maybe you
either.
just statically reserve a third or 2/3 of your write throughput for replica operations. That would make sense, actually. Not 2/3 exactly, but some overall PGs 1 or n-1 over n of the.
But you don't know how much of your traffic is reads versus writes all the time, though.
That's true. Anyway, that'll be a thing to think about as well.
Yeah.
Maybe we could consider some simple but useful QoS policy. Do we consider to implement client QoS like QMU at library? Yes, this is locally and not distributed and not scalable. It's a local QoS sorter like QMU.
You mean just for multiple clients on the same host, or using the same multiple disks within the same VM?
Yeah, maybe.
Yeah, I'm not sure. I'm not sure exactly what you mean. Like having higher level policies for controlling it.
I'm not sure yet. Maybe. I have no idea now. Yeah, maybe that's missing.
Yeah, we could potentially have a simpler setting than the 3 different values that like one for VMs that you don't particularly need to have any reservations for, but they get some proportional share, and they have some throttle limit, and then another setting for VMs that actually have some minimum reserve or provisioned IOPS, we call it, just so it's a bit easier to use. All right. Any other questions about this or ideas?
So on a completely separate portion of this topic, as I understand it, I'm a big fan of the DM clock algorithm, or at least the ceiling I've seen that I think might work, so I like it. But it definitely involves trusting the client who's sending you that data, right?
Yes.
Has there been any discussion of how we might broaden that for untrusted clients and not just people who are stuck behind a hypervisor? Or do we think it's totally feasible?
We already have trusted clients.
Well, okay, but
yeah, I don't think we've talked about that in general.
What trusted client are you talking
about? Public cloud where they're locked into their own namespace or whatever, which actually ought to work now, but certainly QoS under that scenario we wouldn't want to trust them with.
Yeah, I mean, in that case, kind of the conservative thing to do would be just to give them like harder limits and not like you could have some setting on the OSD perhaps that would just reject any QoS settings from those like subset of clients, or perhaps have a Ceph capability that says whether you're allowed to send QoS settings or not. And if the OC doesn't see you have that capability, it simply applies a default policy, which is perhaps more conservative, just like if just giving you some
that makes
proportional
sense.
share and not a provisional.
QoS for RADOS, so I wasn't sure if we had seen some extensions where like you could share signed OSD certificates certifying how much IO you'd gotten from them or something weird like that.
No, we haven't really talked about that at all.
Okay.
Also, hang on, if you don't send a certificate, what does that mean?
That's
send
a good
an empty
question.
one. That means you get more IO, right? Not less? You'd have to
I have no idea. I just made up that sequence of words.
I understand, but you'd have to prove that you didn't send, that you didn't get a certificate, not that you did get one.
Yeah. Yeah. I mean, maybe you could do it based on session age or something. But yeah, let's not try and
Think of any way to do that
right
that
now.
doesn't saddle the OSD with remembering every client that's talked to it over the last hour. At least.
Yeah, I think the easiest thing to do is to be conservative and apply a default policy, which won't overburden the OSD. It's definitely a larger problem to try to do it in a trusted environment, untrusted environment. Well, and that's true of not just QoS, but RADOS in general.
Yeah. No, that's fine. I just wanted to make sure I hadn't missed something.
All right. Any other ideas or questions?
That's all she wrote, huh?
I guess so.
All right.